So at this point, I want to again welcome you to today's webinar on visionary student concepts for Florida's future corridors. I'm Christine Williams, and I'll be moderating today's session. I direct Cutter's research program in planning and corridor management, and this is one of the most exciting projects that I've been involved in because it gave us the opportunity to work with our students and really learn from them as well, and it's been a wonderful experience for all of us. The project, just to give you a little background about it, was sponsored and made possible by the Florida Department of Transportation. The title of the project, Engaging Transportation Students in Florida's Future Corridors Initiative. And about a year ago, the Office of Policy Planning contacted us and said, we're interested in just hearing from students and getting some ideas of visualization, visionary design concepts related to our overall effort to kind of think about the future transportation corridors here in Florida. And as some of you may or may not know, Florida DOT is engaged in a Future Corridors initiative to plan for our major transportation corridors over the next 50 years. And that initiative is being led by the Office of Policy Planning. So the idea here was, well, let's get some student teams together and charge them with developing some visionary concepts that look at what would a future corridor look like? How might it operate in 50 years or more? And think about what would be a range of modal alternatives, innovations and technology, some trends and conditions that might influence those outcomes. And ask the students to come up with some presentations, posters, and a summary report, which we've provided for you in your downloadable materials. And I encourage you all to take a look at that as well to give you a little bit more insight. The project manager for this was Maria Cahill, and I'd like to acknowledge Maria's assistance and help throughout this effort. And as I mentioned, I'm the principal investigator, and we also had a number of faculty advisors involved from here at USF, Trent Green in architecture, Dr. Abdul Panjari in engineering, Dr. Yu Zhang in engineering, and also Jason Bittner, who has a background in freight. And so without much further ado, I just wanted to introduce that briefly and just note that, again, these are student concepts. The students were given free rein to explore their creativity, to come up with some ideas. We didn't constrain them financially in any way. And also, of course, these are student ideas and not necessarily those of the Florida Department of Transportation, but we were pleased to be able to present them to the executive committee. And so today's presenters that are going to present the concepts, first of all, we'll hear from Casey Jarrell, who's pursuing a Master of Civil Engineering degree, and she's also a student of the National Center for Transit Research. Danny Shupp, who's pursuing a Master of Urban and Regional Planning in our new Urban and Regional Planning program here at USF. And Nikhil Menon, who's pursuing a PhD in Transportation Engineering. And so without further ado, again, I'm going to turn it over to Casey, who's going to introduce the ideas and concepts of her team. Casey?
Okay, hello everyone. My name is Casey. I'm here representing the Team A, which consists of myself, Mohammad Reza Kamali, Singay Saliki, and Christian Stanley. Just to give everyone an overview about what I'll talk about today, I'm going to discuss the vision, the different innovations that we came up with, and then the proposed concepts using those innovations. For our vision, we focused primarily on the corridor stretching from Tampa to Orlando. Our main focus on this corridor was I-4. The goal for our vision was to create a corridor that was accommodating to all users and designed using environmentally friendly concepts. We really wanted to create a corridor that would help boost the economy in this region to benefit everyone nearby. For this project, we focused on a few different concepts. First, we looked into what could be done to improve the current roadway design. We wanted to create a better roadway system for everyone who's going to use it. We also focused on bettering the existing transit systems. Another priority was to make the movement of freight more efficient in this region. That will once again back up the economic boost that we really want to achieve. And then finally, we wanted to bring those transit systems that I mentioned before together in a conveniently located multimodal system. We decided to look at trends to really back up our vision and support our concepts. One of those trends involved truck traffic. From this graph, it can be seen that there's going to be a considerable increase in truck traffic by the year 2040. And since we are considering this vision to be in year 2060, this increase in truck traffic will actually be even greater. Another trend that we considered was the millennial and mobility trends. This trend supports the point that young people are more open to using developing technology. Also, these same young people are more willing to use public transit as opposed to their own personal vehicles. Since these young people will be the majority in the year 2060, or at least one of the top contenders for a generation, it was important to keep them in mind when developing these concepts. From this image, it can be seen that the majority of funding for transportation is spent on roadways. And my group really thought that this was a really inefficient and unsustainable idea of funding. Only so many lanes can be built for a roadway. We believe that this funding would be better spread further into public transportation options. This will give people the capability of choosing various modes of public transit instead of heavily relying on their personal vehicles to get around. To the innovative strategies, we really wanted to include several in our ideas for our vision for 2060. It was important to consider technological advances that will be heavily used in the future. Some of those advances include smart, connected, and autonomous vehicles that will be predominant in the future. I believe IEEE said 75% of vehicles will be autonomous by the year 2040. Another developing technology we considered was the solar roadway, which is known as the Tarmac 2.0. We also wanted to implement modular sections that can be placed into the roadway. And another concept was to create easily accessible multimodal centers that will act as a hub to various transportation modes. And finally, we looked at managed lanes, really focusing on a truck lane in particular. Okay, so from this image, you can see what our vision of I-4 is. The first thing you may notice is the high-speed rail traveling down the center and the median going in both directions. Right here, you can see the implementation of the modular sections being placed into the roadway. These can be created off-site, which can actually create an increase in safety for both workers and construction workers and anyone who helps in this design process. And in the darker area right here, you can see the implementation of the Tarmac 2.0. This is the smart roadway, that solar roadway that I mentioned earlier. It's capable of harvesting solar energy that could be used for any needs necessary. It is also capable of charging electric vehicles. So it was important to use in the future because the majority of autonomous and connected vehicles are predicted to be electric vehicles as well. These connections of the Tarmac 2.0 can be placed in short links over long stretches throughout I-4. This will allow for those electrical vehicles to traveling great distances to gather the charge that they need to get to their destination. You may notice that there are 4 lanes traveling in each direction. Due to truck trends that I informed you of earlier, we felt it was important to add a truck lane along I-4. And this truck lane will really create an ease of flow for trucks, and they will be able to move more freely and get to their destination more quickly, allowing for a more efficient truck movement system. This will help to boost the local economy as well. This truck lane can even benefit the general use lanes by getting those big trucks out of the way, which results in an increase in visibility and in turn safety. You may have noticed the barrier that separated the truck lane from the general use lanes in that previous image. This barrier will be equipped with solar panels throughout their span, just like with the Tarmac 2.0. These solar panels will be able to harvest solar energy that can be used for any of the needs necessary. With the implementation of modular sections, seen here, you can see that there's now a plenum space underneath where you can put cables or any utility wires that are necessary now or in the future. From this image, you can see the cross-section of the roadway and both above grade and ground level. Once again, you can see here that the barrier is separating the general use lanes right here. And the high-speed rail will be traveling here through the center lanes. And the elevated view of the rail, this will really be how the rail can exit I-4 to get to its destination, which is actually the multimodal centers. And this rail will really act as a connector between the three cities that will each have a multimodal center. And from this image, you can see those three cities, which will be Tampa, Lakeland, and Orlando, which will each be gaining the luxury of having a multimodal station. Each station will vary, but all are accommodating and easily accessible by anyone. These multimodal stations were important for us to add because of the recent success in other cities, including a multimodal center that was implemented in North Carolina that had a heavy increase in revenue for the surrounding areas. The use of the stations here would really benefit the economy here in this region. And just to briefly mention freight movement once more, we are going to make sure that the Freight Logistics Center in Winter Haven will be able to easily access the truck only lane on I-4. This will make it easier for those trucks to quickly reach their destinations. Just to give an overview of one city in particular, here is Tampa. The populous areas in this city will benefit from adding a bike sharing program, diverting people away from using their personal vehicles. Instead of using their car to go to lunch, they could easily hop on a bicycle and be there and back in no time. We also wanted to keep the existing local bus system in each city, but perhaps increase the amount of routes to give people more options when it comes to using that local bus system. We also wanted to implement an autonomous carpooling option. This will allow for people arriving at the multimodal center in Tampa to use an autonomous car to travel with others to similar areas nearby. This could be really beneficial to anyone who's commuting to Tampa for work. That way they can get an autonomous car with coworkers and not have to worry about driving to that city. It was important to keep the existing BRT system as well that will extend throughout each city, once again giving people more options when it comes to using that BRT system, and this will divert people away from using their personal vehicles. And here are the travel sheds of each of those modes just discussed, new and old, in Tampa. Orlando is very similar to Tampa in that we amplified the same existing modes and added the autonomous carpooling option and bike sharing program. Lakeland is much more rural than the previously discussed Tampa and Orlando. Therefore, we determined it wasn't necessary to implement the bike sharing or autonomous carpooling programs at this time. However, these can be easily implemented in the future if the demand is there for it. With all these modes of transportation available in each of the cities, people will be more drawn to using these modes rather than using their personal vehicles. This increase in connectivity with new and existing modes will result in healthier and greener environment, which is beneficial to everyone in the region. So our vision of 2060 is one that shows a corridor that is accommodating, environmentally friendly, easily accessible to anyone that needs to use it, and can be easily expanded throughout the entire state of Florida, leading to an economic boost. With the implementation of these concepts that I spoke with you about today, we believe this is the corridor of our future. And now I'll pass it to Danny from Team B.
Thank you, Casey. Again, my name is Danny Shupp. I'm here to represent Team B, which consisted of myself, Patrick Buddenbrock, Noor Amores, and Jessica Dahamata. I'm going to go ahead and go through our vision, moving on to some innovative strategies and technologies that we used in these corridors. I'll then introduce the rural, suburban, and urban future corridors that we designed. Following that, I'll discuss managed lanes and then some more ideas. I'll conclude with some more ideas we have for 2060 and beyond. Our vision was to develop an environmentally conscious multimodal design for future rural, suburban, and urban corridors that could be applied throughout the state either as new construction or as a retrofit. We were really focused on trying to develop these designs so that they could be implemented on any of Florida's corridors, either the current ones or the ones that we develop here in the future. One of the major concepts we wanted to focus on were complete streets, a huge trend these days. And essentially a complete street is a roadway or a street designed to accommodate all users. You'll notice the difference between the street on the left and the street on the right. There's a lot more pedestrian accommodations with wider sidewalks. There's more delineated, easier to see bike lanes, and more transit options available to all users, really balancing out the roadway system in these situations. Another concept we really wanted to focus on was the redesign of intersections, mostly to promote safety in bicycle users. Typically, a bicycle will wait here on the left side of a vehicle in a right-turning situation, whereas the Dutch have redesigned their intersections to keep bicyclists to the right of vehicles at all times. This promotes a safer experience for the bicyclists. They don't have to worry about weaving in and out of traffic, especially in this major point of conflict here when a car is trying to turn right and a bicycle is trying to continue straight. You'll also notice there are some curbs here to promote bicycle safety as cars and bicycles are turning at the same time. And believe it or not, these intersections are actually not any wider than a typical intersection is that we designed today. Rain gardens are another concept we wanted to really focus on in these corridors. These can be really great tools for collecting stormwater runoff, reducing the amount of flooding that can occur. And here in Tampa, we all know that Fowler especially is really bad about flooding. Bayshore, another good example. And looking at these pictures, rain gardens, they don't have to be ugly. They don't have to be ditches in the road. We can actually put some really nice plants in here and complement them with the right kinds of soils. They can filter out some of the nutrients that are in this runoff. And to take it one step further, we even considered implementing cisterns below the ground that could collect this filtered water so that it can be then reused for irrigation. Some of the technologies we wanted to include are listed here. We've tried to include as many as we could in the designs. One that I wanted to point out specifically is the piezoelectric lanes. These are roadway lanes that have special generators below the surface that actually collect energy through the vibration of the vehicles on the road, and then that energy can be stored and implemented in a variety of different ways that I'll discuss in just a second. Another one of the technologies we used were indicators on the roadways. These indicators actually glow in the dark, and they're activated in certain weather conditions, such as ice on the roads or cold roadways. They'll come up like this. Wet roadways will come up a little differently, just to really improve safety and make drivers more aware of what their surroundings are like. Interactive roadway lighting is something that we also wanted to include. This is very similar to the Tarmac 2.0 that Casey just discussed. This roadway can actually allow users to know what is happening on their road. Is there something on the road? Is there an accident? Is there an animal? It can also let them know speed limits, and we wanted to include with this type of interactive roadway lighting, street lights that are also interactive. When there are no vehicles present, the street lights wouldn't need to be on. It saves energy. And then as the vehicles approach, the street lights turn on. And then as the vehicle passes, the street lights turn back off. And we suggested using piezoelectric generators or solar panels on the street lights to supplement the energy required to use these surfaces. Inductive charging is another strategy we really loved. we wanted to put inductive charging plates below the surfaces of the road, and as electric vehicles drove over them, they could be charged without stopping to plug in at any kind of station. And this is one of those exciting case studies. Gumi, South Korea has been using an electric bus system. One of their bus routes is actually charged using these inductive charging plates. The plates are under about 5 to 15% of the total route, and they're off until one of the electric buses passes over it, where they then charge the bus throughout its route. And it reduces the amount of batteries required to be carried by these buses. Again, just a very nice, environmentally conscious, environmentally friendly solution that we've included here. To point out some of the benefits of using these technologies and strategies, we suggested that additional revenue can be generated to offset the cost of constructing the highways with this new advanced technologies. An example of that would be users paying a fee to use the inductive charging. We thought that the inductive charging lanes could be segregated from the highway, and you would need to use an electronic tolling mechanism such as SunPass. You would drive off into the inductive charging lane. You would drive however many miles necessary. Your car would then be charged, and you can exit back onto the regular flow of traffic. The energy necessary for this inductive charging could actually be provided from the piezoelectric generators that are in the road, and any remaining energy could be sold back to the power company. It's an addition of a renewable energy source, really helping to protect the environment, which is something we were very focused on with this project. I wanted to start by describing our rural concept for our future corridor. You'll notice the rain gardens that I discussed. It'll help to mitigate some of that stormwater runoff. And we also suggested green energy farming, solar panels, wind turbines, anything like that could support some of this interactive roadway lighting, that could support some of this energy generation. We also designed a rail system along this corridor so that the agricultural, the food collection, and distribution could actually be sent to the more suburban and rural areas through this rail system. Moving on to the suburban concept, you'll notice that same rail system is integrated into the suburban concept, where the people that are actually eating the food can have access to it. We really wanted to focus on complete streets in these types of areas, a lot of pedestrian and bicycle accommodations. We really wanted to move away from that suburban, that sprawling feel, and include some infill housing and infill development with parks and open spaces. And again, you'll see the rain gardens that are included in this corridor as well. The urban street concept, I notice immediately every time I look at this, is the integrated bike lanes that we discussed earlier, as well as just more of that complete street integration, more accommodations for bicycles, more accommodations for pedestrians, and even accommodations for the transit. We included transit-only lanes in this to help make transit a more favorable option, and really try to give a variety of modes in these situations. We also wanted to promote land use integration to really support a vibrant, walkable urban street concept. This is our above-grade concept, really focused on like an interstate or an expressway. We really loved the idea of using the space below the overpass for public uses. We could put parks, we could put open spaces under it, and then we would actually have access from at grade level up through to the center of the expressway, where users could use their transit modes in segregated transit lanes, even HOT or HOV lanes, high occupancy vehicle or high occupancy transit lanes. And these are the situations where we would be using the inductive charging. I think I-95 and I-595 has really proven to us how effective the express lanes can be here in the state of Florida, and we decided, in combination with some movable medians or zipper barriers, this could be a very innovative strategy to use in future corridors. The zipper barrier is something that Michigan has been using in some other places recently across the U.S. For work zones. they'll use this machine that moves the barriers for work zones, and then it replaces them at the end of the working period. These have been done with a perfect safety record and are actually suggested that they're safer than barrels or cones because of the ability to absorb the energy. And people tend to just focus more when there's a more permanent barrier in place like that. This is an illustration of how we may use these barriers. They could be used to delineate the separation of traffic, and you'll notice any of these spaces highlighted in red could be used as HOT lanes, general purpose lanes, depending on what the level of service is and the peak times of day that we're experiencing this. Contraflow situations in work zones are another place that these barriers are used. It's noted that about 8 miles of the barrier can easily be moved in about 45 minutes, making this a very feasible concept for increasing or decreasing the amount of capacity on one side or another of the road. Traditionally, we've been dealing with HOT lanes in this type of situation. We'll have 3 general purpose lanes and 1 HOT lane, or 3 general purpose and 2 HOT lanes, which really requires quite a bit of capacity. We've decided with movable barriers we can actually reduce the amount of capacity and get the same effect of these. We'll have, in one situation, the use of the zipping barrier could provide 3 northbound lanes and 2 southbound lanes and very quickly be changed so that it's 2 northbound and 3 southbound, depending on the time of day and the level of service required. And then these can be converted into HOT and HOV lanes with the addition of more movable barriers. It would be strange to talk about a future presentation without talking about vehicle-to-vehicle or vehicle-to-infrastructure connected vehicles and automated vehicles. It is clear that this is a trend we're moving towards, and we really wanted to focus and we really wanted to address these as we move on towards 2060 and beyond. The safety of these was what we really liked. The ability of your vehicle to understand its surroundings and possibly even act on those surroundings before you even know what's going on is excellent. We really wanted to try to include some of these concepts. So in doing that, we outlined a corridor that would have a roadway surface, and below that a piezoelectric generator. And that generator would then be used to power the inductive charging lanes that we discussed before. And kind of getting out of the state of Florida a little bit, we wanted to possibly include heaters below the roadway. In situations where there's icy road conditions, we can just use the heaters to clear the roadways, making a much safer situation, mostly for the colder climates. And incorporating the automated vehicles, you'll notice that in this design there are there's no lanes and no road delineation. We've decided in 2060 and beyond, it's possible for the vehicles to communicate with each other and communicate with the infrastructure to get a really good idea of how to align themselves so that the optimum level of service and the optimum speeds can be achieved in these situations. The flow of traffic will be very close together, and it'll happen at much higher speeds. Those are some of our ideas, and with that, I'd like to pass it along to Nikhil for him to present Team C's ideas.
Hi, my name is Nikhil, and I will be presenting my ideas that we have been presenting as part of Team C. So Team C, consisting of Josh McDonald, myself, and Eric Pullman, we have been working on the Future Corridors project since September, and we would like to go into our design. But before we go into our design, I would like to just focus on the aspect of urban sprawl. Urban sprawl. This is a photograph that has been taken by a very renowned urban photograph and enthusiast who goes by the name of Christoph Gielen. This is coastal Florida, and he's trying to show the effect of sprawl that is virtually unseen for most of us, because these are all aerial photographs which he's taking from a particular height. Something that I want to draw your attention to is regarding the aspect of on the deficiency of planning. So as you can see, this area where you have 2 houses which share a boundary wall, and the time taken to drive between those 2 houses is 20 minutes and 9.3 miles. So this is again in the state of Florida where we have seen this kind of a trend where you have the separation of residential, commercial, and educational areas which discourage land use and make the private car more of a prosthetic device, more than that of an independent choice of the user. So this is something that we would like to address in our corridors when we do the vision. So our vision primarily involves changing from this element of commercial sprawl into building more complete communities, and the presentation will go on and try to explain how we go about doing this. So we start by proposing modal alternatives to the future corridor. We believe that people should have a duality in mode choices with different modes of transportation for the seamless movement of people. We believe that we need an overall reduction in transfer and waiting times and also in the vehicle miles traveled. How do we achieve this? We achieve this by 2 points. One, the first point is by having new modes, and the second is by optimizing the existing modes that we have. This is aimed at inducing mode shift, and it's also aimed at reducing capacity bottlenecks. Second thing that we want to focus on here is the movement of people. We believe that we have to respect the autonomy of the individual, but then we have to also ensure that we ease the flow of the masses. So again, coming to the same point where I focus on the movement of people rather than the mathematical movement of vehicles. So the picture below is very self-explanatory on what mass movement can do to a roadway condition that you see in this photograph. Next focus that we want to do on the future corridor is on mass transit. For the efficient movement of people will require the use of non-personal vehicles, especially in urban areas and for inter-urban commute. This has to be seen as an economic and personal priority in the days to come, because we have been witnessing a lot of trends, increasing trends in car ownership for the urban areas, and we feel that it will come to a stage where we are going to have to think about these measures. So next section that I'm going to emphasize on is on the innovations that we propose to do. So we first start by the aspect of new modes. The first mode that we propose to introduce is an express train service along the interstate corridors for the state of Florida. Passenger rail transport operating between the extents of the future transportation corridor. An operating speed range could range between 40 to 80 miles per hour. And we believe that we need to do something called an incremental investment on rail infrastructure, which basically means that we build tracks which are capable of taking high-speed rails, but we start with the express train services with the option of doing an upgrade based on the demand, so that we don't waste a lot of money by investing on the high speed just before we see the demand. So that is more of an incremental investment on infrastructure. Second mode that I propose here is the bus rapid transit system, which we intend to apply along the state highway corridors. The bus rapid transit systems will operate as the connectors between the suburban and the urban, and also along the internal urban routes. We are proposing an operating speed of 35 to 45 miles per hour, a zonal pricing. Again, here we are doing an immediate investment in fleet with minimal investment on infrastructure, because most of the infrastructure that a bus rapid transit system needs, the cost is very less compared to the fleet that we are going to invest on. Bus rapid transits can operate on existing roads with updated stations serving population centers. Next, we come to the aspect of optimizing our existing modes, where we feel that planning for transportation has to be done in relation to the demand anticipated. That is, we envision a transportation system which is going to be dynamic with respect to daytime and economic activity. Planning based on cultural events by extracting information from web sources and GPS data monitoring to study dynamism in demand. We also propose an optimal scheduling based on the schedules of the new mode, whereby what we achieve is we achieve an integration of sorts, whereby we try to reduce the travel and transfer times. So what are the key trends that are influencing this design? The major trend influencing this design is the fact that we are looking at an uncertain future. we are unable to exactly predict what is going to happen with most of the how we move or how our mobility patterns are going to change. So we are looking at an uncertain future, and the planning will involve a very conservative approach to planning at this point in time. We would like to quote the study done by American Public Transport Association, who have through their research found out that fewer millennials look to cars for mobility. So if you can see below, you have the 5 modes. There was a survey which was conducted by the American Public Transport Association, which asked the millennials to rate the 5 modes based on a scale of 5. So as you can see that the bus system receives a 4.34 on a scale of 5, whereas the car receives the lowest at a 2.24 on a scale of 5. Another key trend that we'd like to influence, that has influenced our design, would be the last mile connectivity, would be the aspect of last mile connectivity with lesser travel and transfer times. So there were a couple of questions again on the APTA report of 2013, which interviewed millennials asking what would they like to see in their transportation options, and these were some of the aspects that they were focusing on: more reliability, more real-time updates, user-friendly, Wi-Fi, 3G, etc., etc. Another major trend that has influenced our design is the importance of efficient freight movement from an economic and regional standpoint. So this is the state of Florida. These are the freight flows that are occurring from the state of Florida to the rest of the country, and you can see that it has grown. It has been a growing recognition of importance of freight and business travel in the field of transportation demand. So this is going to be one of the major trends that will influence our design, which I will be discussing in the coming slides. We are trying to shift from the predict and provide model to the predict and prevent model, where we are trying to accurately predict what is going to happen, even though forecasts are usually mostly very difficult to predict. What we are trying to do is we are trying to get to a stage where we do not have to go back and do a lot of repair work on our investments. Another key trend that influences design would be sustainability, which is something which has a lot of focus on the modern day. Now we come to the last part of the presentation, where I try to envision the future corridor that we are going to present before you. So for the sake of the proposed concepts, what we have tried to do is we have divided all the roads in the state of Florida into 3 broad categories. The first category is the urban arterial, the second category is the state highway, suburban, and the third category is the interstate. So as you can see, this is a current scenario in an urban arterial, a very typical urban arterial that we have drawn from the state of Florida. These have been generated through street mix. So as you can see, you have turn lanes, you have drive lanes, and you have perpendicular parking on either side. And this is like a current scenario for a typical urban arterial. This is a proposed alternative that we tried to do. This is a plan and section view, and I will be going into a more detailed view of this in this slide. So as you can see, what we have done is we have taken off the perpendicular parking to the off street or to the other streets, to the side streets, and we have tried to include a bike lane on either side, and we propose to reduce the number of lanes on the main road by 3 from 4. So in doing so, what we intend to say is we expect a mode shift of sorts, and we expect the number of people using their private modes to decrease inside urban arterials. Next, what we are trying to show here is these are the differences from the current corridor conditions that we see. So this is a typical urban arterial here, where we are trying to show what would be the differences that would come along in our new design with respect to the current design. Next, we go on to the state highway suburban section, where we try to again do a very typical state highway suburban section. We have turning lanes and we have driving lanes as well. You have perpendicular parking with sidewalks on either side. What we propose to do for the state highway suburban is the introduction of the bus rapid transit system. So the bus rapid transit system would be taking one end of both the sides, and we would have the drive lanes and the turn lanes as they have been there before. One thing that we have taken off from this is the perpendicular parking again, and we feel that the perpendicular parking could be taken to an off-street level. So we have sidewalks, we have shelter for transit, as you can see, and this would be a typical proposed alternative for a state highway suburban section. This is the state highway suburban section in more detail if you are interested to see the greater details of it. As you can see, there is a 2 feet separation between the BRT lane and the normal drive lanes here. This is again a proposed plan and section view of the same section. This is to give an overall idea of how this will look like. So you have the bus rapid transit lanes in blue here, and you have the other turning and drive lanes. This again shows the difference from the current corridor conditions. You will have the bus lane over this, and you will have the drive lanes here. You have a drive lane here, and you will have the normal turn lanes here. Lastly, we come to the current infrastructure that we see on an interstate. The current infrastructure on an interstate is a typical interstate is consisting of three lanes of drive lanes, and we have a shoulder and a median on either side, and you have a strip that is a huge median of over 45 feet in the middle. So this is where we intend to bring our light rail into the picture. The light rail, the express rail, the express rail would be running between the medians of all the interstate corridors. You'll have a typical station design, which is very, very basic for the sake of presentation. Something that I would like to stress here is the existence of the autonomous freight lane. We envision that autonomous trucks would be the first kind of automation that we will be seeing in the future, largely because of the excessive truck traffic that the state is witness to, and also the fact that the trucking industry is something is an industry which can bring automation at a large scale level in a very easy manner. So we envision an autonomous freight lane and in our interstate corridors, which are going to be separated by from the other drive lanes as well. So this is something that we feel is going to be we feel is going to have a lot of significance over the coming years. So this is again a plan and section view of the proposed alternative of the interstate that we have designed. So you can see the blues are the express rail corridors. The first lane here is the autonomous truck lane, and you have the normal driving lanes on either side. So with this, I would like to conclude by presenting the final slide on the differences between the current corridor conditions as we have shown. So you'll have the express rail coming over the medians, you'll have a dedicated truck lane, you'll have a median between the dedicated truck lane and the normal traffic, and you have the drive lanes on either side. So this is our corridor concept for Team C, and I would now like to leave the floor open for questions.
Thank you, Nikhil, and I want to remind everybody that there is a Q&A option at the upper left-hand corner of your screen. To click there, you can submit questions for our presenters. And we've gotten a few in already. One question related to whether the students received some sort of compensation for their efforts. And yes, as part of the project, each student received a $1,500 stipend in order to support their efforts in the project. We also had a small budget for printing of posters and other needs they may have, and travel to and from Tallahassee for them to present the results of their work. And the next question I'm going to open up to the project teams. And the question comes in from Joel Valinsky. Team C it's focused to Team C. How frequent? So this, Nikhil, how frequent would bus service need to be in your view, to justify a dedicated bus lane on an arterial?
Yeah, so what we felt was for the bus rapid transit system on the suburban highway, on the suburban highway sections, we felt that we would need they would have a frequency of one bus every 3 minutes along the route, which is more or less the kind of standards that you would expect for a demand. Uh, catering the state of Florida. The thing is, we are unable to fix on a scale on the frequency just as of yet, because we are unable to see what would be the expected demand. But we would expect a decent response on the aspect of BRT, and that's why we have currently arbitrarily fixed it at 3 minutes per bus on the BRT lane.
Okay, thank you, Nikhil. Our next question comes in from Marcy Jaffe. I hope I pronounced your name right, Marcy, who says, fabulous, thoughtful, and bright, hopeful presentation. Thank you for the variety of displays to help us see your vision. By the way, I want to mention that those displays were, in fact, prepared by the students, and each team had an architecture urban design student to assist with that. Her question is, did you develop a priority for which phases would unfold first? It's a multi-part question, so perhaps I'll start with that. Did you, sorry, this screen just got very small for me. Did you develop a priority for which phases would unfold first? Any of the team have a response to that?
I would say that this is Casey from Team A, that we felt like a lot of our project focused on the multimodal centers, but I would say that if this were going to start tomorrow, that it would probably start with the truck lane, just because of the obvious increase in truck traffic. So if it had to start somewhere, I think it would start with the truck lane.
I have the same opinion on the truck lane. This is Nikhil from Team C.
This is Danny from B. We actually we discussed it, and we like the idea that we included a series of different strategies that could be applicable in a variety of situations, and in some situations they weren't applicable. So it would really depend on each individual corridor which strategies will be most useful first, and then so on. Was kind of the route we decided to take on that.
Danny, just kind of as an add-on question that Marcy had, what are the operating costs, do you know, for the zipper barriers? Could an agency afford to move 30 miles each day, taking 4 hours to move the barrier each day? And if an alternate option, we move rail to the center median, is there sufficient height at overcrossings to implement now, or would those need to be rebuilt? Any role for better transit information to nudge riders to alternate modes? So those are several questions, actually. But let's take the zipper barrier.
Yeah, I can jump in with the zipper barrier. We when we first found this zipper barrier concept, it was a very limited concept, mostly used for work zones. So I don't know offhand what exactly the cost would be to do that on such a large scale. I assume there are some costs involved, but I would be surprised to see that the cost of increasing the capacity to add 1 or 2 extra lanes as express lanes, I would be surprised if that cost would be lower than using these zipper barriers over an extended period of time. But that was just our very rough idea for this corridor.
Okay, and I'm going to move to the other question. Any role for better transit information to nudge riders to alternate modes?
Hi, yeah, this is Nikhil from Team C. I feel that in order to in order to nudge people into alternate modes, well, it's more about educating them on what their cars, I mean, what the, what their single occupancy cars have been doing to their driving standards and and the condition that they face on an everyday scale, and also the fact that when we are proposing an alternate mode in a public transport, in terms of a public transit, we need to really be catering to the service quality expectations that these riders may have, because they have been used to their cars. And I would think that when we propose an alternative mode, we would have to go for a really high-end proposal of public transit, which would make it attractive for them to do the shift from this mode to that mode.
And I would just like to add that we really focused on the millennials and how their views of using public transportation has really changed, and that, you know, fewer young people are actually getting their license because they'd rather be texting and riding a bus rather than driving and not being able to text or basically stay connected to social media or whatever other technologies are out there. And so I think something that could be done is just really marketing to the millennials and focusing on getting them to start and then have others follow.
Thank you, Casey. Another comment that was offered by Howard Smith, as you're thinking about refining your concepts and ideas, Howard mentions one of the recommendations was to build rail for future high-speed rail, but use it for lesser rail technologies first. That phasing, I think, that Nikhil had talked about. And he mentions, bear in mind the huge curve radii for high-speed rail designed for 350 kilometers per hour or 220 mile per hour speeds. Therefore, all sections have to be rather tangent.
Yeah, that's something that we had the small discussion when we were thinking on what we had to do with the infrastructure, or I mean, the other option would have been to start with the lower, with the lesser rail technology and build the same build the infrastructure for the same, and then take it all out and build for the new high-speed rail. But then this is something which has been done in a lot of European countries. Portugal, for instance, had developed something like this, bearing in mind that there would come a time when spending on infrastructure would take a while. And now what they have tried to do is they have brought on their high-speed trains on the same infrastructure with very minor improvements, which may not have been possible had they not thought about the incremental infrastructure aspect at the earlier stage. So this is more of an inspiration from what has happened in Portugal as well, in Portugal and probably the other countries as well.
Thank you, Nikhil. And then a last question. I think I have time for one more. Are arterials without lane markings something that most modelers are anticipating with automated connected vehicles? Or is this your idea?
This is Danny again from Team B. We were sitting and brainstorming together, and we kind of got to the point where we were really trying to think outside of the box, and we got to this idea of, if all these vehicles are automated and connected, why on earth do they need lanes to tell each other where to go? So for the purposes of this presentation, yeah, this was our idea. I do not know. I haven't seen any research or any kind of documentation of modelers that are using these concepts, but I'm sure they're out there. I'm sure we're not the only people that have thought how interesting it would be for automated vehicles to kind of take over and work themselves rather than us having to delineate them in any way.
I might add that one of the interesting features of the presentations the students did that we didn't share with you today was a video of an intersection with fully automated vehicles and that had no signals whatsoever. And I think that kind of was an interesting one to watch, that simulation. I I want to point out, we have a few more questions I'll try to get to, but also to encourage you to complete your evaluation of today's session, because it certainly does help us out, and it's on your screen, so please do that as we're wrapping up here. Marcy had asked, how would you market to millennials, as many of our future will not have driver's licenses? Any specific thoughts?
I would really focus on saying, just by starting to remind them that you can use technology as you're on the bus, and then as opposed to if they're having to drive a car, then they're not. And I think that younger people are becoming more environmentally aware. So I think Nikhil mentioned this too, of really mentioning the differences that they can make will have an impact on what they will do.
Okay, well, thank you. And Howard says he's excited about many of these concepts. I'm glad to hear that. I think many of us are. It's just thrilling to see what our future professionals are thinking about, and I think we all have a lot to learn from that. So thank you again for your participation in today's webinar, and please do complete your evaluation prior to logging out. And with that, I'll turn it back to Stephanie.
Thank you, Christine. And just as a reminder, as you're completing your evaluation, that this webcast will be submitted for AICP credit, and the recording will be available on the Qatar website within the next coming days. And again, the recording is also available for AICP credit. Thank you very much for attending, and we'll see you again in 2 weeks.